Hello everybody and welcome to the InduSoft webinar, Soft PLC integration with InduSoft IoTView. First of all, I'd like to taking the time to thank you, each one of you, for the support during the past 15 years. It's really only because of our customers and partners that we are able to keep evolving our product with innovation and success. So it's really important you are a key part on this relationship. Here we have the agenda for the day. My name is Paulo Guerra. I'm working with the consulting services team for InduSoft, and I'll be doing a brief introduction to the IoTView, our newest runtime edition of InduSoft Web Studio. Then I'll be passing control to Cindy Hollenbach from Soft PLC, which will be talking a little bit more about the smart control systems, Soft PLC, as well as the IoTPAC, which is the combination of the Soft PLC hardware with our software IoTView. Soft PLC has been a partner from InduSoft for many years. In fact, they have their own private label version of InduSoft Web Studio called Soft PLC Web Studio. So whenever you're choosing to use their hardware, their platform, you can buy everything together on a single package, both hardware and software. And Cindy will be talking a little bit more into details about these possibilities. And last, we will be opening our Q&A section. So throughout the webinar, feel free to type questions on the Q&A box, and we'll be answering as many as possible at the end of the presentation. So let's start talking about the IoTView, our newest runtime edition for target markets, the new and exciting market of the IoT, of Internet of Things. So let's start taking a look and understanding why we choose to invest and develop this new product. So here we have some driving trends for this market. So one of most important there, so 15 times growth is expected to have a 15 times growth in the machine-generated data by 2020. So we're going to be seeing a big interoperability between machines. And with these new connections, all these new machines connected, you'll be seeing way more data being stored. So it's expected a 15 times growth in the stored data by 2020. So what a lot of people refer to, kind of the buzzword big data nowadays. Third one here, we have one of the most interesting, in my opinion. Only 15% of the devices are connected nowadays. So it's a good timing as well to choose to invest in this new market. And most important, there's an estimated $19 trillion value for this market. So a huge opportunity for all of us, software developers, machine builders, hardware manufacturers. So a really big opportunity there. So that was the driving factors that made InduSoft invest and create this new solution. Now, when we talk about the Internet of Things, we're really talking about these devices, all these smaller devices that are going to be connected, generating, collecting this data, storing this data. So what are the most important platforms nowadays for these devices? So we have there Windows CE, Windows Embedded, which already present a strong position nowadays on the industrial HMI world. And as probably many of you know, InduSoft was the pioneer on creating a SCADA HMI solution for this platform back in 1997. So we already covered this spectrum of the platforms, but we also have VxWorks with nearly 40% of the traditional real-time operational system shipments nowadays. And third, we have Linux, which represents more than 25% of all embedded shipments, and that's excluding Android. So if we include Android, which is a variation, a flavor of Linux, then this number is way bigger. So those were the three big players as far as platform goes. So with that in mind, what were InduSoft goals to create this new solution? So first and most importantly, we wanted a platform agnostic product. So pretty much a product that would be able to run on many platforms one of the key characteristics for this new market on our view is that we won't have anymore a single big player like we had Microsoft for the past years. So it's going to be important to be able to run the solution on different platforms, which include Windows, VxWorks, Linux, and many more to come. We also wanted to have a rapid application configuration environment. So unlike most of the solutions nowadays, we believe it would be important, even on these different platforms, to be able to very easily develop your application. So instead of having to write lines of code, commands on a terminal to a black box, we wanted to keep very easy for the engineer, for the developer to create and configure their application. We also wanted to keep the footprint of this product very small, because pretty much many of these devices, they are dedicated devices specific for a given functionality, so their footprint is way smaller, even as hardware requirements. So we needed to keep our solution small to be able to run on these smaller devices. Interoperability. As I mentioned, that's one of the key characteristics of this device, of this market. So it was really important to try to add as many as possible existing technologies of nowadays to this new solution, which included device protocols, or what we call the native drivers, OPC technology, connections to historian database, so that you could store all this information that's been generated. You could store this information to the cloud, so send this information to a remote external database or historian. We wanted to make this solution mobile, so not only from the runtime perspective, but we also wanted to be agnostic from the visualization perspective. So we wanted to be able to visualize this solution, visualize the application that you're running on these devices from any device, so being very mobile. So that's why we choose HTML5, and we're going to talk a little bit more about that in the next slides. Remote management. So just like the ones that are familiar with our CE solution, for example, we wanted to have an easy way to deploy your application, to send your application to these devices. Again, have an easy way to develop that using a developing environment, configuration environment, and then very easily be able to send this information, this application, this project to the device. And last but not least, affordability. So these new markets is about these smaller devices, these dedicated devices, and many times these devices are going to cost a fraction of traditional HMIs running Windows from nowadays, for example. So it was really important to make this solution affordable, so have a high volume business module. Okay. So here we have a slide showing all the portability. So again, the idea that you'll be developing your application on a single integrated development environment, so using InduSoft Web Studio on a development station. And once you are done with all the configuration, all the development, then you can choose where you want to deploy the solution to. So you can choose to run that on the InduSoft Web Studio full runtime that runs on top of Windows full operational system, so either a Windows Server 2012 or a Windows 10. For example, we just got a certification to run on top of Windows 10. Or even you can run using our embedded view, running on top of a Windows embedded device, or even under our Windows CE, the CE view platform that runs on top of HMIs running Windows embedded or even headless devices. And now we are adding a fourth possibility called the IoTView, which is targeted for the Linux and VxWorks devices. So again, the concept that you're going to develop just once and then be able to deploy your solution anywhere based on your customer needs, based on your application needs. So what are the features that we currently support nowadays on this first release of the IoTView platform? So for those of you familiar with our development environment, I broke the items here just like our tabs on our development environment. So under the global, we have project tags, classes, system tags, and security system. So pretty much we support everything as classes, so you can mimic the classes to mimic your project, create the classes mimicking your project, creating the tags, use already security system on the local mode. On the graphic side, as I mentioned, we want it to be mobile, so we choose to use the SMA Team Client as the visualization engine for this new solution, and we already support screens, screen groups, and our library of symbols. So you can create your own linked symbols or use any of the symbols available in our library. Under the tasks, we have Alarm Online, so you can generate alarms whenever things get out of areas or range specified by the developer. And we have the Trend task as well, so pretty much be able to save your data, the data that you are generating, to a remote database or remote historian. So again, the idea of the big data. And last, we have drivers. So on this first release, we have a couple drivers, Modbus TCP, AB TCP, TagWell, that Cindy will be talking a little bit more, and MQTT. So the idea with this platform is to continue growing and add features to that. So on the next release, you see that you keep evolving the product, just like we've been doing with the C view, for example, or the embedded view. And eventually you have a very good subset of the full InduSoft Runtime Edition. So now talking about mobility, as I mentioned, we wanted to be able to access the visualization portion of this solution from any device. So now you can run your project on any device, run Linux, VxWorks, CE, full Windows, but now you can also visualize this application from any device, any platform. So you wanted to make the visualization portion also agnostic. So you can choose if you want to visualize your application, access your application using a Windows, Android, iOS, or even a Linux device. Not only the platform is agnostic, but also the host, so pretty much the web browser that you want to use to visualize that application. So now it's a personal choice for you to make if you want to use Internet Explorer, Chrome, or Safari, or Microsoft Edge, Firefox, and so on. And we did that through the use of HTML5, so state-of-the-art technology which does not require any sort of add-ons or ActiveX components, .NET components. So now the client is really completely free of any add-on installation to visualize your application. And those screens that you are seeing though on the slide here, those are real-world applications, and actually, in fact, the PC demo that visualizing through a mobile access. Now, talking about flexibility for deployment. So, as we show on the second slide, so we have our portfolio. It's very broad on how you want to deploy your system, how you want to develop your application, depending on your customer needs, on your own needs. So you can have the application running on a server, on a Windows server on premises, for example, or you can even run your application on the cloud. It's becoming very popular nowadays to hire or to pay monthly fees to use a third-party infrastructure to host your application there. So this way you do not have to handle and to work on the IT side. All of the IT sides handled by third-party customers, so Amazon, Rackspace, and so on. And you can have this main system talking with local HMIs that you have installed throughout your process, throughout your factory, talking with headless device, mobile devices, and now this new IoT device, so this new Linux VxWorks device. And then you can choose how you want to visualize these applications. So you can still use the web team clients whenever you are using a full version of InduSoft Web Studio, or you can use a secure viewer, so pretty much dedicated stations to visualize the process all the time, or use the Studio Mobile Access, so our HTML5 solution, to visualize your application from any platform, from any device. Really important to highlight the Studio Mobile solution or the Studio Mobile Access. The SMA is not only limited to the IoTView, but it's available for also for the embedded view and for the full InduSoft Runtime Edition. So this is kind of giving you an idea of how flexible our portfolio is whenever you have to choose how to best create your application for your customer. And here we have a last slide kind of showing how do you envision this evolution to happen. So what we currently have nowadays on most of automation systems is something similar to that, where you have your PLC, your Soft PLC on premises, communicating locally with a computer, a SCADA server, pretty much isolated. Everything is centralized on that machine. And then you have traditional Internet Explorer access using ActiveX components to be able to visualize that application. So what we see with this new market, the Industry 4.0, the IoT, is that now we're going to have hundreds, millions of smaller devices also connected, interconnected between them, but also collecting data and pushing this data to a centralized system, to a centralized database, a centralized enterprise system, either running locally on your premises or even on the cloud. And then you'll be accessing this, visualizing your process from a single point, of view. And again, now you will no longer be tied to a specific platform, but you have the option to choose how you want to visualize, how you want to access this information. So you'll be able to use any of the existing platforms and different browsers to do that. So pretty much the goals with this solution is to have a distributed data acquisition, manipulation, and control. So I highlighted there manipulation because we are really not just talking about collecting data. It's not really not a data acquisition. We are really talking about having control and manipulate all the data on these smaller devices nowadays that you can embed it, a full HMI system on top of their the operational system, and then push this data to then a centralized management. So what we have, what are the characteristics and requirements with this solution? So you have a scalable, so large number of devices pushing all this data together, generating a lot of data. So the big data needs to be secure. So we need to be encrypted, filtering, and remote notification. So you have to have remote notification capabilities. It needs to be a platform agnostic solution, both from the runtime, but also from the visualization side, from the client sides. And it needs to be simple, easy to configure, deploy, and maintain. We really believe that, and that's why we wanted to keep using InduSoft Web Studio as a development environment and just download the application to this new runtime edition called IoTView. Compatibility, really important. InduSoft has a commitment to always keep backward compatibility. So any investment that you make to create, to design, to deploy your application using InduSoft is a investment that is protected, because pretty much InduSoft has 100% commitment to keep 100% compatibility with the applications designed in previous versions. So meaning that if you develop an application nowadays to run on top of a given version, 2 years down the line, whenever there's a new release, you can rest assured that you'll be able to run this application with no rework, no new investments made in order to make that happen. So here on the slide, we have an application that was developed using InduSoft version 1.0 back in 1997, running on a Cassiopeia at the time, and this application was imported to InduSoft version 8, and it just runs. So you can rest assured about this protection of your investment. Okay, thank you very much. I'll be now passing control to Cindy, who will be talking a little bit more about the Soft PLC and also about IoTPAC, and then you'll be coming back for the Q&A section. Thank you.
Hello, everybody. I want to apologize. I was traveling and I caught a cold, so I hope my voice doesn't hurt your ears, but we'll get through this here. Wanted to start just give an introduction to our company and our products, and then talk about how Soft PLC and the IoTView are integrated, and then some applications that are really exciting for this new technology of putting these two things together. Soft PLC was actually founded back in 1983, and we've always been an industrial software company. In 1988, we released the very first Soft PLC. So that was a long time ago. We were one of the first to create a Programmable Automation Controller. And as things evolved, we've added to the product. We've ported it to Linux. We've added a whole lot of great functionality. And in 2013, we released a product called TagWell, which is our cloud-based platform for Internet of Things or Industry 4.0 type applications. And now in 2015, along with InduSoft IoTView, we now have the IoTPAC product. So our product line includes Programmable Automation Controllers, which is our Soft PLC, also gateways or protocol converters, so we can take data from one network to another. We also have Soft PLC Web Studio that we sell as software, but we also package it onto panel PCs and headless PCs so that we can provide HMI-type products so that you don't have to do that integration yourself. We've got Windows CE, Windows Embedded, and Windows systems for that. And then we have our TagWell platform that we'll be talking about some more as we go through this presentation. So those are our four main areas of products. We do have other products, but these are our four main ones. When we look at the Soft PLC Programmable Automation Controllers, a lot of questions that first come up is, just what is a Soft PLC? There's been a whole lot of people who use different definitions for that term. So first of all, Soft PLC is not a PLC. PLCs are, ancient technology. They're relay replacers. They're great for small ticky-tacky machines, but when you want to do something fancy, then you want a Programmable Automation Controller. And so Soft PLC is a Programmable Automation Controller, which means it has better communications, data handling, advanced functions that you don't find in a traditional PLC. And Soft PLC is truly open architecture. We don't provide push buttons and sensors and drives and all the other pieces that go into an automation system. And so it's very important for us to be able to communicate to hundreds and hundreds of other vendors' products. The other thing Soft PLC is it's not a PC-based controller. It does not run on Windows. We don't have a screen or a keyboard or a mouse. We run on very small footprint type hardware with no moving parts, no hard drives, and it runs like a controller. So it's deterministic. You can do run mode program changes. It's not a compiled program. And the maintenance people or the engineers are going to troubleshoot it like a PLC. You have forced I/O, all the same functions you're used to seeing when you go in and try and troubleshoot a PLC system. So it's a blend, and what we do is we actually take our software, which is the Soft PLC, and we put it on an industrial computer along with our Linux operating system, and we turn that computer into a controller, into a Programmable Automation Controller. And a little bit different than a lot of the other computer-based controllers that are out there is that we've modeled our PLC after an Allen Bradley PLC. It's partly because of our history in supporting Allen Bradley PLCs with software in the past, but also 70% of the installed base in the Americas and Canada of PLCs is Allen Bradley. So there's a lot of people that understand the programming. There's a lot of built-up engineering knowledge and code base that we can take advantage of. And one of the things that we do is convert Allen Bradley PLCs to Soft PLCs by importing the logic. It's not even a conversion. It's actually an import. And then all the advanced features and open architecture can be added onto that. So it's in a very affordable way to allow customers with older technology to move forward. These are some of our hardware models. The Smart Soft PLC is probably the bulk of what most customers are using. It can span from small applications up through very large redundant systems. It's priced to compete with a small PLC like a Micrologix or an Automation Direct PLC, but it can scale up to be larger than even a ControlLogix. We're replacing DCS systems with the Smart Soft PLC. And so what we're shown here is some different configurations of the Smart. This one here, the modules mount right on it for smaller applications. This guy in the back will connect to our I/O racks, and we can do up to 12 local racks, and through Ethernet distributed I/O we can do hundreds of racks. And then this one here without any ports on it is meant to connect to serial, Ethernet, Profibus, DeviceNet, those kind of I/O systems. And what we've shown here is that we can actually connect directly to the Allen Bradley I/O. The Hardbook Soft PLCs are our high-end models. These are used by customers who need a lot of PCI slots for add-on cards, or maybe they want a rack mount system, or maybe they need something that's really, really fast, or other reasons that people go to a hardbook. But this one here is actually Class 1 Div 2 rated, and so we use it when we have hazardous location applications. Our micro soft PLC, as you can see, is very, very small, very, very low cost, but it's got all the same power of our other systems, just less ports on the communication side. We use this a lot in our IoT applications, remote applications, or very, very small embedded machine controls. So if we look at the standard set of features, these would apply to all of our PLCs. These are firmware type features. The Smart actually got a built-in Ethernet switch. All of our PLCs except the micro have multiple Ethernet ports so that the I/O and the communications can be segmented onto different subnets. And an option for our PLCs is an embedded firewall or VPN option for firmware. And this allows the system, especially if it's remote and you're worried about somebody, coming up with an Ethernet port and tapping in and doing something, gives you some security in the PLC itself, as well as in remote applications or networked applications. But if you're using something like TagWell or some other cloud application, that structure already takes care of the protection, so the firewall would be another layer if you wanted it. Soft PLC can also be a remote access switch, so you can connect in through phone, or you could put an external modem and connect in through cellular. But once you're in, you can connect to anything on that network. So you can do remote maintenance, firmware updates, look at what's going on, and also it can call out for remote alarming applications. Soft PLC can also be a data logger. Maybe you don't need to do any control, you just want to do some data acquisition and logging. We can do that. And there are a number of blocks that we have to do data logging to different formats. So we can go to CSV, you could go to a database format, or we have a binary format for high volume logging where the file is going to get very, very large, and or you're doing very high speed logging and you don't want to be doing it to a text format. And the log file can be directed to any drive. It could go to the internal flash, it could go to a network drive, it could go to the cloud, or it could go to a USB stick. So you have a lot of options on the data logging of how that's going to work. The Soft PLC can also be an alarmer, and you can do that through email or text messaging. The email also supports attachments, so you could have a report that gets attached to an email to tell someone what their production was at the end of the shift or that sort of thing. And so that is built in as well. And of course it is a controller, so it runs ladder logic, runs some function blocks, and it also runs C++. The logic is virtually unlimited. You have megabytes of memory. Our smallest controller is 63 megabytes of user memory. So you can do all kinds of things in there, especially if you're doing a lot of recipes or data handling. You've got enough memory and data table to do that. You can connect to multiple different types of I/O simultaneously. And as I said, it's open architecture, so we can talk to devices from hundreds and hundreds of vendors. And as far as communication goes, you also can configure the PLC to support multiple networks. And so you can connect to any HMI or SCADA system or GCS system via standard protocols like Modbus, Modbus TCP, DF1, other Ethernet protocols, Profibus, all those kind of things. And we also can talk peer-to-peer to other PLCs. So if you've got Modbus devices or Allen Bradley PLCs or other Soft PLCs, they can send messages back and forth. So there's a very rich set of communications as well as a rich set of I/O interfaces. So along those lines, if you don't want to do any control, you could just set this up as a protocol converter. It's a very low-cost way to be able to simultaneously send data between a lot of different networks. And there's no limit on the number of words. Like I said, you've got 100 million words of data table and up to 16 different protocols that you can communicate simultaneously. TagWell is its own product. It is a cloud platform that provides an applications interface that people can run applications in the cloud. One of the applications is a web browser interface, so that you can build web pages and do bidirectional communications to remote systems. So when we have a Soft PLC that's talking to TagWell, we call it a remote, and you can both read and write to TagWell and from TagWell to these remotes. Once the data is up in TagWell, it can be sent to browsers. It could go to Web Studio. There's a TagWell driver for Web Studio. You could go to other SCADA packages, or you could have just an application running that would send the data to an Oracle database, for example. And the remote can be a controller, so it's a system that sits out there standalone. It's controlling the application as well as communicating to the cloud. Or it could be a gateway that is communicating to other devices that are doing some of the control and then sending the data up to the cloud. As more and more vendors provide cloud-enabled devices, you could end up with a very large cell bill at, for example, an oil well, whereas if you had all those devices going in through a gateway and then one device going to the cloud, you can save a lot of money, as well as have all that data concentrated to minimize the traffic on that cellular network. So TagWell itself is the platform, but there's a loadable block or function that is free that comes with every Soft PLC that allows the communications from the Soft PLC to TagWell. The next thing we're going to talk about is a virtual HMI. So what's a virtual HMI? That means that it's a headless system. There is no monitor on the system, but it can provide HMI functionality via HTML5 to a web page. So we have two ways of doing that. One is there's an embedded web server option for Soft PLC. We actually were the first controller to support a web server. And with that web server, you can build pages. You can use any development environment and build pages that are bidirectional to read and write to the data table through any web browser. Now, we also have the option for IoTView. So in the Soft PLC, the IoTView will run and provide a more robust development environment. You have all the tools of Web Studio to do fancier displays, very easy development, and you don't need to know HTML5. You just need to know the Web Studio part of it, as well as the function of the IoTView to do the remote database interface directly. So it's another way of doing the same thing, but it's a lot easier development, and it uses more of the things that the controls engineers are used to doing. Now these pages can be viewed on any Ethernet connection, wired, wireless, or any internet connection, which could be cellular, satellite, or any way that you're going to get to the internet. So if we look at Soft PLC, it's kind of like a Swiss Army knife that provides a very rich set of functions that you can pick and choose based on what your application requires. They're all in there, they just need to be enabled. And so let's segment just down to the IoTPAC and talk about where we're going with that. If we look at the Soft PLC architecture internally as a block diagram, we have something called Gatecraft Linux, which is our Linux distribution that runs in every Soft PLC, and that's the base operating system. And then the Soft PLC kernel, or the Soft PLC runtime software, is the executive. It decides what tasks are going to run, how much time they're going to get, make sure everything's talking to each other and passing data back and forth. And so then we have pluggable interfaces called APIs that get the data out to the real world or to other applications to make it happen. So this yellow interface is the Allen Bradley Communications Driver Interface. At this level, Soft PLC looks like an Allen Bradley PLC to other programs such as an HMI, the TCToc programming software, other Allen Bradley PLCs, or even C++ programs. So there's different Allen Bradley protocols that are supported at that interface level. Additionally, there's a TCP/IP stack in the Soft PLC which provides access to services like FTP, SSH, or NTP for Network Time Protocol time syncing. So through the FTP and SSH servers, from the network, you have access to the Soft PLC flash, so you can do remote updates of files, access reports or text files or log files that the Soft PLC may generate, firmware updates, update the web pages that are embedded into it, and that sort of thing. Down here at this level is our C++ interface. We have a toolkit that provides this technical detail to people who want to write their own C code to run in the Soft PLC or to access Soft PLC via C programs. And this can be used for device drivers, which could be any kind of I/O or devices, USB I/O, serial I/O, any of the standard protocols that are used in industry, that sort of thing. Serial protocols, Ethernet protocols. You can also use this interface for custom instructions. So I've talked about a few of the instructions that we have, like data logging and email and TagWell, but there are literally hundreds of others, and a lot of customers create their own just because it's a very nice way to protect your proprietary technology or to make the system truly efficient. For example, we had one customer that did Fourier transform functions. You'd never want to do that in ladder logic, so he wrote some C code to do that. We also have our web server down here, which allows a web browser to view the pages and get the data table information embedded in those web pages. And then the last piece we're adding here now is the IoTView. So the IoTView runs within the Linux environment, and it talks to Soft PLC through a driver at this interface level here, and has full access to the data table of the Soft PLC, just like if it was running on a Windows box and talking to the Soft PLC over Ethernet. The IoTView also, through other drivers, have access to, for example, Modbus TCP through this layer to talk to I/O or other equipment that might be on that network. And then the IoTView is going to generate the HTML5 pages, which can be viewed in a browser. So as we look at the kind of solutions that are out there for automation, we have the traditional PLC HMI combination. This has been around since the 80s, where we have, whatever controller you want and whatever HMI you want connected by some kind of communications protocol. Then a couple years ago, actually more than a couple years ago, there's been a whole host of products that have rolled out that are combined PLC and HMI. These tend to be lower cost, lower functionality type products, just because their target market is simpler applications where you don't need a lot of I/O and you don't need a lot of SCADA type functionality. You just need an HMI. And now we have the IoTPAC, which is the controller with the embedded headless virtual HMI. And this table is just my way of, I guess, kind of say, okay, here's my application, what do I want to choose? And it's going to depend very much on the application and what you need. But as you can see, you can save money, save maintenance costs, reduce the size of your cabinet, reduce the energy use of the total system by getting rid of that screen. And then now I'm going to talk about some other applications and reasons why you'd want to use the virtual HMI. But, it's not a great solution if the operator needs to stand there and look at the screen all day, or he needs to constantly, be touching the screen to do things. But it's a great application where you don't need that constant interaction. One other thing I want to mention here is you can have the HMI running in the PLC and access it through a wireless or Bluetooth or hardwired connection. But if the remotes are connected to TagWell, you can actually put IoTView in the cloud as well. And there's a TagWell driver from IoTView, which would allow this instance of IoTView to access any one of these remotes. So it gives you a great low-cost, cloud-based access method for a whole lot of remote systems. This is an example of one of our customers' installations. This is the Microsoft PLC, and it's mounted on an I/O board here that has some relay outputs, some digital inputs. This particular board also has a solar power battery monitoring circuit. So if you've got a remote system that's powered by a solar panel, you can have the PLC provide warnings and alarms when the batteries are not functioning properly or there hasn't been enough sunlight or whatever. We also have here a modem, a cell modem, so that we can get to the cloud. So this whole system, without the solar panel itself, is less than $800. So it's a very low-cost way to have a very powerful system that is bidirectional, cloud-based access, data logging, control, HMI, everything. So now I want to talk about some other applications of where this IoTPAC concept might come in. It is called Internet of Things, but there are also applications that have nothing to do with the cloud where this makes sense. So maybe we have a bunch of machines in a plant that we start them up, we load the recipe, and then it just runs on its own for days. Maybe it's a little process that needs, like an oven that's going to do a heat treating cycle, or just a small machine that just kind of clicks away and nobody needs to touch it. So why have the HMI there? It adds cost, it adds complexity. So someone could just come by with a tablet or a laptop access the IoTView screens, do what they need to do, and then disconnect and go on to the next one. So this is a nice solution, like I said, for certain types of machines. Some systems, especially OEMs, you just can't compete if you're going to put a nice fancy panel PC on the system. Again, if you don't need that all the time, you only need it periodically, take it off, put in the IoTView, and let someone use their phone or their tablet to access the screens when they need to. This is another example. We obviously don't need an HMI up flying around on a drone. So here we can put in like a Bluetooth connection or something like that and look at what's going on while it's flying around. So we don't need to have the HMI on the system in those kind of applications. Another good example is vehicle-mounted systems. HMIs that get put onto these type systems tend to be very, very expensive. High vibration, drastic temperature changes, bumps and rattles and that sort of thing. So the IoTPAC makes a lot of sense here because, again, when it stops and you're ready to look at things, you just pull out your tablet and you're ready to go. This particular system here is one of our customers. They do remediation where they're cleaning up a oil spill or something like that, and they were constantly having the HMI break or die because of the temperature. And so the IoTView, they're in the process of retrofitting their systems now to use the headless virtual HMI. Remote systems is one of the key uses that we see for this. Again, nobody's there. Why have an HMI sitting there? Whether it's a hazardous area or it's hot or cold or whatever, you've got a lot of cost in a high-end HMI to live in that environment. And so by eliminating that, you can just reduce maintenance, reduce cost, and all those sort of things. You still got all the functionality. The PLC can do the logging. The IoTView could do remote logging to a remote database in the cloud. So you're not losing anything by eliminating the screen. Some other remote system examples. This is a pump station. The Soft PLC is sending the data to TagWell, and then we've got a SCADA system that's grabbing it off the other end. So the HMI, when there's a problem, the guy can show up and plug in his laptop and pull up the IoTView screen for his detailed troubleshooting. Here's some other remote systems, just examples. I'm out in the cornfield or whatever those, I guess soybeans or whatever those are. I've got a weather station here. For example, we did one system that was monitoring the river levels feeding into a dam. There's nobody out there. It's out in the middle of nowhere. So we don't need an HMI, but we need that functionality if something's wrong and we need to go look at it. Submarines, another good example here, where we don't need to have the HMI all the time. So what I'd like to do now is just kind of show you a live demo of a system. I've got a Microsoft PLC here in the office that is running the Soft PLC and the IoTView, and it's also doing some data logging. So let me get out of here. And so this is the PLC ladder logic. Those of you that know Allen Bradley PLCs can see that it looks very much like Allen Bradley PLC. I'm going to go to this program, and down here, what we're saying is when the tank level is low, we're going to send an email And so that's what this little subroutine does. I'm going to shrink this down a minute. Look at that. And now I'm going to load my browser. And log into the IoTView. Get rid of that. And so here's the IoTView login screen and just some of the functions that we can do. I'm going to go to this screen here and a tag monitor. And this particular one, when the tank is low, I can request the truck to come. And it's going to send out a request, and then a little bit later you'll see the truck come and it'll fill up the tank. So while that's happening, we're going to go to this other screen and look at a well monitoring screen. And you can see it's a standard Web Studio type screen. You can see the values here reflected over here in the top dock in the PLC. So you can see that the data is transferring between the two applications in the PLC. I just had a fault here. We have alarms. You can see the drive faulted. I can here it is. I'm going to acknowledge this alarm. I can enter a comment. And you can see that the alarm has cleared now. I can do trending. And you can see here the values here are going to reflect over here. And we have our standard Web Studio type trend functions available in the IoTView. Let me see if my, no, not yet. Okay. I go back to our screen, and we filled the tank, and now it's getting lower again. And we should be getting an email any minute now. There we go. So the PLC sent the email to tell us that we had this alarm because of the condition that we had set on that rung that we looked at earlier. Right here. So as you can see, we've got that very little box, if you remember what that micro looked like, doing all of these functions. Let's look at the log file real quick here. That's the other thing I wanted to do. I'm going to just go into the actual Soft PLC itself just to show you. We're generating this CSV file from the Soft PLC to the flash disk in the Soft PLC. And if I wanted to look at it here, you can see the data, but that's not what people would normally want to do. So instead, what you could do is, let's say we do a FTP transfer. Let's log into the PLC. I'm going to go home, log, and there's that file, and we can view it here. and you can see that that data was sent to the CSV file that we can look at it with Excel. It's an extremely powerful set of tools here. Oops, let's say yes. And go back here. And here's some contact information. If you guys have any other questions, feel free to contact us or go to our website, take a look at the products. We've got downloadable demos of both our programming software for the PLC as well as the Web Studio. And I'll turn it back over to Paulo.
Thank you, Cindy. Very nice presentation, great demo. Thank you again for participating with us. So now I think we still have a couple minutes here, so let's try to answer maybe one or two questions. So we have one question asking, okay, so we see the IoT, that incredible, huge market, so save in minutes. Are you focused on the end user or on the OEM or both? So what is the expected market price for a node versus server in software and hardware? Okay, so I'll give you some idea here as far as software, and then Cindy might want to conclude a little bit more there. But pretty much we are, at InduSoft, we are both on both ends, so both end user as well as OEM. As probably many of you know, InduSoft is known on the OEM market. So yes, we are interested in working on the both ends of the market. Giving some idea as far as pricing goes, we are releasing the IoTView product, and the price is similar to our CE solution, so our CE View solution. So just give you a ballpark number here, an idea. So a 4,000 tag CE View runtime edition costs roughly $1,000, and that's about the same for the IoTView. And if you go for the full InduSoft runtime edition for the same 4,000 tags, you're talking about maybe $1,700 or so. So yeah, we are targeting both markets, and for now the price is very similar to the CE View price list. Cindy, do you want to make any comments on that as far as hardware pricing for?
Yeah, I would say for the IoT, what we're finding is two things. One is you've got the oil and gas market, which consists of end users who want information about their wells, but you also have the OEMs, like the people who have tanks that either inject material into the well, or well servicing companies that are servicing lots of end users that are very, very interested in having this remote connectivity because it cuts down on their logistics costs. The other big market we're seeing is municipalities, where they have a lot of these remote systems that previously were connected by radios or lease lines, and they're trying to cut that cost way back and go cellular. And so that's an end user, but it's a large number of nodes typically. But there's also systems that are, garbage collection, where they want to know when the trash cans are full so they can determine where the trucks are going to go. So it's an end user, but it's hundreds and hundreds of nodes. As far as cost on those smaller systems that we're talking about, for example, the IoTView for 150 tags is only $150. So it's very, very low cost. As I mentioned, that one example I gave, that whole panel, the cabinet, the modem, the PLC, the IoTView, the I/O, everything was under $1,000 for everything. So you can scale way down, or you can scale way up if you've got a larger system. Perfect.
Thank you. Yeah, and there's another one. I think you touched a little bit about that during the presentation, but it's asking if you have cellular wireless compatibilities. It sounds like you have, right? So even the example you provided during the presentation. And I think those were the questions, and we actually are running out of time as well. So Cindy, again, I would like to thank you for participating and presenting with us. I would also like to thank you, everyone that participated on the webinar, that watched the webinar today. And keep an eye open as we'll be hosting more webinars in the future. Thank you. Bye-bye.